In this section, we're gonna talk about Norton's theorem. First, I will give you Norton's theorem, explain a little bit, then give two examples and two exercise questions. Norton theorems. Basically, if you have any linear two-terminal circuit, we can replace this circuit by one current source, one parallel resistance. So here is IN is short current, short circuit current through the terminals. RN is shows the equivalent resistance from the load side. How are we gonna find them? Here the explanation. First, if we're gonna find the IN, we're gonna take the load resistance value out. We're gonna make that short, the terminals A and B. Then we will try to find this current goes from A and B. That current is our Norton current, or we can call this one is short circuit current. There is a relation between Thevenin and Norton. If you're gonna find the R, if you know the VTH and RTH, we can find also Norton currents too also. So when we come to find the resistance, equivalent resistance value, we have two cases. Case one. In case one, if there is no any dependent sources, we will turn off all the independent sources. Then we're gonna look at from load side, looking for from that side, from looking this side here, we're gonna find the total resistance value, which is R in will be equal Rn, or same thing will be equal RTH2 also. Second case is like this. If we have a dependent sources, in this case, we're gonna again turn off all independent sources, not the dependent sources, okay? And we're gonna apply voltage sources at the terminal A and B. We can apply 1 volt voltage source. Then we can find the current goes from here. Then we can find the equivalent resistance value V0 divided by I0. Alternatively, we can do different way too also. This way here, we can include current sources here. Then we're gonna find the voltage between A and B. Then we can find Rn2 also. I usually select voltage source, for me easy to do it again. Okay, here is example. First example is there is no dependent sources. So when I look at this one here, we have independent current sources, we have independent voltage sources here. A and B right there is open already. There is no load resistance value right there. So to find the again Rn, we will turn off all the independent sources. Turn off means current will be open, you can see right there. Voltage source will be short circuit here. When you look at from this side here as Rn, we can see that AD plus 4D plus AD serial, then 50 ohms here is parallel. So that's why we say 4D plus AD parallel to 50 ohms. When you simplify it, we find the Rn is 40 ohms. In this case here, we're gonna try to find the IN, this case here, IN, current sources, or Norton's current value. Again, between A and B, we're gonna make short circuit here. So we'll try to find this current right there. This will be our IN. We still have the voltage and independent voltage and current sources. So in this case, you will see this 50 ohms is nothing there anymore because we make short circuit. There is no effect of 50 ohms anymore right there. When we look at here, we can write mesh equation or node equation. Mesh equation is, this is I1 right there. Easily we can see that I1 is equal 0.2 ampere. Why? Because this is the one going right there, you can see right there. The second mesh will be from here to all the way going this way here, because that 50 ohm is not there anymore. So if we start from right this point right there, we're gonna have negative 12 plus, we're gonna have 40 ohms plus 80 ohms plus another 80 ohms times I2. So we have here 40 plus 80 plus another 80 ohms times I2. Then we can say negative 40 I1 equals 0. And we know the I1 value here. That's why we can have negative 12 plus, this is 160, 200, I2, negative 40. This will be here 0.2 will be equal 0. This will give me another value there, 8. So I2 will be equal negative I2. So you're gonna have 12 plus 8 divided by 200, which is give you 0.1 ampere. Okay, so this is the equivalent current source value. So when we represent it, we can see one current source, parallel resistance, equivalent resistance value. This is the example for us. Let's look at one exercise question here. This is a similar question. In this case, we don't have any dependent sources. So we're gonna look at how we can find the Rn and In values. Let's find the first Rn. Okay, we're gonna turn off all the sources. So this will be short right there. This will be here resistor. This will be open right there. And this will be resistor value right there. This will be another resistor right there. So we'll look at from here to find our Rn. So this is 120. This is 120 also ohms. This is 60 ohms. So I can see from here easily that Rn is equal 60 plus 120 parallel to another 120. So 180 parallel to 120. I think if you simplify this one, we should have 72 ohms right there. Okay. Now next is, let me change the color here, blue. The next is how we can find In. So In case, we're gonna look at here like this here. We're gonna have the source back. We have a resistor right there. We have this current right there still. We have this resistor right there. We have this resistor right there. We make short between A and B. We connect them together. So this is 24 volts. This is 0.1 ampere. This is 120. This is 60. This is 120. You will see when we make short right there, this is basically nothing there. Okay. I will look at this solution like this here. Maybe I can do this one here. Maybe I will write this one here like this. This is one going in. I know this is going right there. I'm gonna use this one like this here. So this will be here, maybe I1. This is I2 here. If I write this node equation right, if I know here, I will call this one maybe V1 right there. if I know V1, then I can find the I2 easily from there. That I2 will be equal IN, right? Okay. Can I say here I1 going in plus 0.1 ampere going in plus I2 going out negative and equals 0. What is I1? Can I say it's 124 minus V1 right there divided by 60 plus 0.1 negative here. Can I say here V1 minus 0 divided by 120 equals 0. So I'm gonna multiply this one by 2. I'm gonna multiply here by 120. This is 1. So 2 times 24 is 48 minus 2V1 plus 12 minus V1 equals 0. So here we have 3V1 will be equal here, I believe 48 plus 12 is 60. Then from here V1 will be equal 60 divided by 3, which is equal to 20 volts. If I know V1, easily I can find, I think like this here, I2 will be equal here V1 divided by 120. So V1 is 20 divided by 120, that will be equal 0.1667 ampere, or you can say 166.7 milliampere. So this is the IN value. So if you represent the circuit, we can represent the circuit as simple. Maybe I should move the slide a little bit here. Let me see, I can move the slide, I can show it. Right there, we will have like this here. We're gonna have current source, okay? Then we're gonna have one parallel here resistor. Then current source is 166.7 milliampere. Resistor value is 72 ohms. This is A, this is B. And done in this question. There is another way to solve this problem too also. We don't have to use the node equation. We can write mesh equation also too here if you want. In that case, let me see, green. If somebody write from all the way right there, actually, yeah, I'm gonna erase this one here. All the way from here, all the way like this. When you write it, we know this current right there, we can find tools. So there's another way to find it. I will not gonna spend time now. I will go to the next slide. In this example, we have dependent sources. That's why when we find the RTH or RN, we're gonna insert voltage source between A and B. Okay, so basically first let's find the RN. So we need to invert the right voltage source. We did right there actually. We took the independent sources out because of voltage source. This is short right there. If this is short right there, when we look at here, that means this doesn't affect anymore right there. Okay, right? So only here, when you look at here, Ix is 2Ix. What is Ix value when we short right there? Ix will be equal 0. Then when we find I0 here, we're gonna say 1 volts divided by 50 here. That's why give us a 0.02 ampere here. Okay, so we know the I0, we know the V0 right there. 1 volt divided by I0 will give you 50 ohms right there. So this is the way you can find Rn. To find the IN, we're gonna make short circuit right there, and we put the independent source back again. In this case here, Ix right there, we have it. For the ohm resistor, we have it. We have 10 volts between right there, so we know the Ix value because 10 volts divided by 4 they give you Ix. So Ix is equal, what is it, 10 divided by 40, which is equal 0.25 ampere. If we know that one, that means we know this one is equal, what is this one is equal to here, right there, 2 times 0.25. Okay, so we're gonna write a note on the A right there if you write it. So I2 coming here, 2Ix is coming here, will be equal this right there, right? We call I short circuit value, or IN you can call it. So I2 is this one here. Okay, how we can find I2? I2 will be equal, because of the voltage right there, we know it, and this is short right there. I2 will be equal 10 divided by 50. So 10 divided by 50 plus 2. Ix is 0.25, will be ISC. When you simplify ISC, which is IN, comes right there, 0.7 ampere. So with previous one, we found the resistance value, we find the current. We can represent the Norton's circuit basically in this form. I have one exercise question. Let's look at this exercise question. Let's try to find first. Let's try to find this one first. VTH. VTH. No, what do you mean VTH? We're gonna find IN. IN. So what we're gonna do? We're gonna make a short circuit right there between A and B. We have this one here. We have this one here connected. We have this dependent source right there, plus minus. We have this one here, and we make short right there. This is 2Vx, this is 200, this is plus minus Vx right there, this is 600 ohms, and this is 0.1 ampere right there. When we look at it, you will see that 200 ohms is short circuits. So basically Vx will be equal 0. So the source we have right there will be equal 0 volts too, because Vx equals 0, right? Right? In this case means, let me change the color. This current will be go right there, right there, right there. We will not gonna go over 200 or 600 ohms. So I can say that IN will be equal 0.1 ampere. So this is the IN will be equal directly to the source right there. Okay, so let's look at how we can find RN case. Because of dependent source right there, we're gonna take the independent source off. We have this circuit here. We're gonna make short circuit right there. This is here still. This one is still here, plus minus. We have this one here, and we're gonna connect here 1 voltage source, plus minus 1 volts. 1 volts. And we are looking for this current right there. Let me connect 1 volts right there. The values of this one is here 200. This is plus minus Vx. This is 2Vx. We have it. This is 600. Yes. So we know the Vx value. Vx is by parallel to 1 volts is 1 volts. So that means when we have 2Vx here, that will be equal to 2 volts. Yes. Okay. You can do here a couple of steps. first, actually, I can find this current right there easily. Oh, hold on. Make sure this is wrong, right? I want to do this one here. This is short right there, right? Was open should be here because it was a current source right there, right? So I can find this current right there. I can find this current right there. I'm gonna call this one is I1. I'm gonna call this one I2. Then I0 will be equal I1 plus I2. How I can find I1? I1 will be equal here. 1 volts we have right there, 2 volts we have right there. So basically 1 plus 2 divided by 600. No, I think it's 5 milliampere. Okay. When we find the other one here, I2 will be equal 1 volts divided by 200. That is equal also is 5 milliampere. 5 milliampere. So I0 will be equal 5 plus 5, which is equal 10 milliampere. So Rn will be equal here 1 volts divided by 10 milliampere, which is equal 100 ohms. So we can represent this circuit as like this here. We can say we have one current source here, one parallel resistor. This is 100 ohms. This is 0.1 ampere. So this is the final answer here. If you have any question, please provide them. We can answer them in the class.